Hi, my name is Morgan Van Arsdell, and this is our project. So, what is Bayes' rule? Bayes' rule is updating a probability when you get new information. It helps you find the chance if something is true based on evidence. We chose problem one, which is a software company has just bought three software packages to solve an accounting problem. The three different packages are called red, orange, and blue. On first trials, the probability of red crashing is 0.1, the probability of orange crashing is 0.2, and the probability of blue crashing is 0.3. Out of the 10 employees in the company, 6 were assigned red, 3 were assigned orange, and 1 was assigned blue. Cynthia was assigned a program at random, and it crashed on the first trial. What is the probability that Cynthia was assigned blue? And what is the probability that she was assigned red? So, conditional probability. Conditional probability is the probability of an event happening given that another event has already happened. It means we are updating the chances of something based on new information or conditions. And this is the formula. So the probability of event A given event B has occurred is found by dividing the probability of event A occurred and event B occurred over the probability of event B.
Hi, my name is Adi Vora, and I'll be explaining the purpose, formula, and the meaning of variables for Bayes' rule. So, the purpose of Bayes' rule is to update a probability after you get new evidence. So we start with some hypothesis, we get some data, and we use Bayes to revise our original hypothesis. And some real-world examples where we can see this is medical diagnosing, spam filtering, and forensic evidence. So the general Bayes' rule formula is the posterior P(h) of E is equal to the likelihood times the prior, and divide the likelihood and the prior by the total probability. So what do these variables mean? Well, the probability of H given that E, the first variable, is the updated belief after we see our new evidence. The probability of E given that H is true is multiplied by our likelihood, which is the probability of our hypothesis occurring without seeing any evidence. And we divide both of these multiplied together, the posterior and the likelihood, by the probability of E, the overall probability of evidence across all hypotheses.
Okay, this is Emma Wagner. And so our hypotheses and what we want to find. So our hypotheses are going to be R for if Cynthia was assigned red, O for if Cynthia was assigned orange, and then B for if Cynthia was assigned blue. And what we want to find, we're given that Cynthia's program will crash on the first run, so we're going to assign that to C. So the probabilities that we want to find with what we're given is going to be the probability of R given C, which is the probability that Cynthia has red given a crash, and the probability of B given C, which will be the probability that Cynthia had blue given a crash. So assigning the numbers for our priors, we're going to have the probability of R is going to be the 6 employees assigned red divided by the total 10 employees, giving us 0.6. Probability of O is going to be the 3 employees given orange divided by the total employees. And then our probability of B is going to be the 1 employee assigned blue divided by the 10 employees for 0.1. The likelihood, so the probability of C given R is 0.1, the probability of C given orange is 0.2, and the probability of C given B is 0.3 from what we're given. And then H equals one possible package, C is the program crashed, probability of C is the total probability of a crash, and probability of H given C is the probability given a crash. And so our total probability of a crash is going to be this equation. And when we fill in the values that we've solved for in our given, we get the probability of a crash is 0.15.
Hi, my name is Bridget McConville, and I'm going to be talking about the probability that Cynthia had blue, red, and then the final answer and interpretation. So first, to solve this, we use Bayes' rule, which helps us find a probability after new information, which in this case is a crash. We're finding the probability that Cynthia had blue given that it crashed. So we take the probability of blue crashes, which is 0.3, times how often blue is assigned, which is 0.1. Then we divide by the total probability of a crash, which is 0.15. That gives us 0.2, or 20%. Now we repeat the same process for red. The probability of red crashes is 0.1, and the probability that Cynthia had red is 0.6. Dividing the same total crash probability of 0.15, we get 0.4, or 40%. So even though red crashes less often, it ends up more likely. So overall, Cynthia is more likely to have red than to have blue. This is because many more employees were assigned red. The Bayes rule shows that both how likely something is to happen and how common it is will affect the final probability.